There's a theorem that says that the ratio of areas of similar triangles is equal to the square of the ratios of their corresponding sides. If you haven't heard about that theorem, or if you want to learn how to prove that theorem, and if you want to learn how to do some problem questions on it, you have come to the right place, and we are starting right now. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative that helps to add an exponent to your learning curve. In the previous videos, we have learned about similar triangles and what they are and what properties do they have. And we also learned about how to prove the Pythagoras theorem. And we also did some real life examples and took some real life problems like measuring the width of a river or finding the height of a building using the concept of similar triangles. If you haven't seen any of those videos, then just click on the top right corner of your screen and you'll get a link to all those videos. In this video, we are going to concentrate upon the theorem which says that the ratio of areas of similar triangles is equal to the square of the ratio of their corresponding sides. Now let us learn how to prove that theorem. First of all, what we are going to do is we are going to take two triangles which are similar to each other. Let me draw those triangles first. So here we have our two triangles. Let's call them A, B, C, and let this triangle be D, E, F. We have been given that they are similar triangles. They're similar in all respects, which meaning they have equal angles and their corresponding sides are equal. We learned that about the properties of similar triangles in the previous video. The link to that is given on the top right corner of your screen. So let's just review what the corresponding sides are and what the ratios are. So if ABC, we've been given that triangle ABC is similar to triangle DEF, which means that if we look at the similar sides, it would be the ratio of the similar sides. AB is similar to DE, so that ratio is going to be the same as BC, and the corresponding side which is similar to that is EF, and that will be equal to AC, and the corresponding side in the other triangle to that is DF. So all three are going to be equal to each other. They will have the same ratio. Now what we need to find out is the ratio of the squares. So let's call this triangle 1 and this as triangle 2. Now we have the basis for the same. The base of triangle 1 is BC, the base of triangle 2 is EF, but what we don't have is the height. So first of all, let's take the height for both of them. So let me start from vertex A in triangle 1 and drop a perpendicular on the side BC. Now since this is a perpendicular, let me mark it as a perpendicular and let this point be P. Same way in the triangle 2 also, let me drop a perpendicular from vertex D to the opposite side, which is EF. Again, this is perpendicular, so I'll mark it so and let this point be Q. Let us say that the area of triangle ABC will be equal to half times the base, which is BC, times the height, which is AP. And same way, area of triangle DEF will be equal to half times the base, which happens to be EF, times the height, which is DQ. So if we take the ratios of both, we get that the area of triangle ABC over the area of triangle DEF is equal to half times BC times AP over half times EF times DQ. The half and half can get cancelled out, and what we are left with is BC over EF times AP over DQ. Okay, since we are running a little short of space, I'm just going to save the things that I need and remove the other things. Well, so what I needed, I kept it on the top and the other things I've removed. Now let us concentrate on two more triangles, which are triangle ABP, which is a part of triangle 1, and the other is triangle DEQ, which is part of triangle 2. Now, if we look at these two triangles, we know that triangle ABC is similar to triangle DEF. That means that angle B is equal to angle E, because that is already, they're similar, so they have to be equal. So this angle is going to be the same as this angle. And we also have a 90-degree angle in both. So angle P is equal to angle Q, which are both equal to 90 degrees. And we know that if two angles of any triangle are equal to each other, then those triangles have to be similar. So we can say that triangle ABP is similar to triangle DEQ, which also brings us to the relation that AP, which is the height of the first triangle, over DQ, which is the height of the second triangle, will be equal to AB, which is one of the sides of the first triangle, over DE, which is one of the sides of the second triangle. I would need this also later on, so let me take this also up there. Now coming back to the top, let me write this as equation number 1, this as equation number 2, and this as equation number 3. Now let me bring down equation number 2 again here. So we had in equation number 2 that area of triangle ABC over area of triangle DEF is equal to BC times AP over EF times DQ. This can also be written as BC over EF times AP over DQ. It won't make any difference if we write it like this. Next, if we look at equation number 1 right here, we see that BC over EF is the same as AB over DE times AP over DQ, which in equation number 3 you can see is the same as AB over DE, which means that the area of triangle ABC over area of triangle DEF will be the same as the ratio of the corresponding sides, which are AB over DE. You see AB and DE, these are corresponding sides of the two triangles, and since they are being multiplied with each other 2 times, so we can say that the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. The same way we can go ahead and prove it for AC over DF also and BC over EF also. So you take the ratio of any corresponding sides, square it up, and that will give you the ratio of the areas of the triangle. And from this equation, we also got that the heights of similar triangles, since AP and DQ are heights. So heights of similar triangles is also equal to the ratio of corresponding sides, since AB and DE are corresponding sides. Now, how about learning to solve some questions? Okay, let's have this first question here. We have been given that there are two triangles in which triangle ABC is similar to triangle XYZ, and what we need to find out is the ratio of areas and ratio of perimeters of the two triangles. So first of all, we know that the triangles are similar to each other, so their corresponding sides have to be in the same ratio. We don't know the sides of the other triangle, so we will have to work that out. But we know that since we are given this relation, we know that AB over XY, they will be the corresponding sides. They will be the same as BC over YZ, again corresponding sides, which will be the same as AC over XZ. Okay, let us find the sides first, the side lengths first. So let me take XY as X centimeters since we don't know what that side is. But we know that X centimeter, which is the side of the larger triangle, over 3 centimeter, which is the corresponding side of the smaller triangle, should be equal to the base of the larger triangle, which is 12 centimeter, over the base of the smaller triangle, which is 8 centimeter. So the centimeters can get cancelled out. 12 and 8 they can both be divided by 4. So let's do that. So that will give us 12 divided by 4 is 3 and 8 divided by 4 is 2. We multiply both sides of the equation by 3. The 3 and 3 get cancelled, and if we multiply here, we get 9 over 2, which can also be written as 4.5 centimeters. So this we can write it as 4.5 centimeters. Now let's try and find the value of xz, this side over here. Let's take that as x this time. We can rub this off since we don't need it now. The ratio is 3 over 2. Let's remember that. So we have x, which is the side of the larger triangle, and the corresponding side on the smaller triangle is 6. So x over 6 should be in the same ratio as 3 over 2. We multiply both sides of the equation by 6. The 6 and 6 can get cancelled out, and 2 goes into 6 3 times. So we get the value of x as 9. So we can again rub that off and write it as 9 centimeters. Now what we are left with is the value of the height, that this time let's take that as x. So we take the height of the larger triangle x over the height of the smaller triangle, which is 2. That should be in the ratio 3 over 2, since we already proved that in the previous example that the heights are also in the same ratio. We multiply both sides of the equation by 2. The 2 and 2 get cancelled out, and we are left with that x is equal to 3. So we can just rub that out and write it as 3 centimeters here. Now let us try and work out the ratio of the perimeters. So we need the ratio of the perimeters. So let us say that perimeter of triangle XYZ over the perimeter of triangle ABC should be equal to the sum of all the sides. So 4.5 plus 9 plus 12 over 3 plus 6 plus 8. So how much does that come to? 12 plus 9 is 21 and 25.5 over 3 plus 6 is 9, 9 plus 8 is 17. We can multiply both sides, both numerator and denominator by 2 so that we can get rid of the decimals. So we get 51 over 34. Now 51 and 34, they have a common factor of 17. So we can divide the numerator by 17 and the denominator by 17. 51 divided by 17 is 3 and 34 divided by 17 is 2. So we get that the ratio of the perimeters is also the same as the ratio of the corresponding sides, which is 3 is to 2. Now let us find the areas. So instead of perimeter here, I'll just write that as area, and we can obviously rub this out fully. So area of triangle XYZ over area of triangle ABC, that should be equal to half times the base, which is 12 centimeters of the larger triangle, times the height, which is 3 centimeters, over half times the base of the larger triangle, which is 8, times the height of the smaller triangle, which is 2. So the half and half can get cancelled out. 12 and 8 can be divided by 4. So we get 3 times 4. 3 times 4 we get 12, and 2 times 4 we get 8. So what we are left with is 9 over 4. So you see how if we square the ratio 3 is to 2, we get 9 is to 4. So the ratio of the areas is 9 is to 4. We saw that numerically also this time. So tell me, how's it going so far for you? Are you getting the hang of it? Do you think you can do it? Let's try and do some more problems and figure out if it's easy or not. But at this point of time, I would like you to give me some comments on how you are liking it, whether you've learned something out of it or not. And I want to see your comments in the comment section right now. Okay, let's move on to the next problem. And let's move on to the next question. Here we have two triangles, triangle PQR and triangle LMN. We have been given that triangle PQR is similar to triangle LMN. We are given two sides, so 5 centimeter and 12.5 centimeter, and here 8 centimeter and 20 centimeters. So what we are going to do is we are going to find the ratio of the sides first, and then try and find the area of the larger triangle. So the ratio of the sides, obviously let us take the bases because they don't have any decimals. So we can say that the ratio of the sides is 8 over 20, and we can divide both numerator and denominator by 4. So we get 8 divided by 4 is 2, and 20 divided by 4 is 5. So we get the ratio as 2 is to 5. And if we want to find the area of the triangles, we know that it is going to be the square of 2 is to 5. So 2 over 5 square is going to be 4 over 25. So that means the ratio of the squares is going to be 4 is to 25. So we can just write it as 58 over x. That should give me 4 over 25. Or if I take the reciprocals, I can also write it as x over 58. That should give me 25 over 4. I multiply both sides by 58. The 58 gets cancelled out here. And this goes into 58. I can divide both of them by 2. So we get 25 times 29, which will be equal to 725 over 2. And that when we divide by 2, we can get 362.5 square centimeter. So we can just replace that here. We can write it as 362.5 square centimeters. Let's move on to the third question, where we have been given again two corresponding sides are given, but the ratio of the squares we have to find out. So the corresponding sides, I'll take the hypotenuse, looks like a right triangle to me. Anyways, I'll take the hypotenuse of both the triangles. So 15 over 5, that should be equal to 5 goes into 15 three times. So 3 is to 1 is the ratio. And if I take the square of that, it should be 9 is to 1. So the area of the squares, which mean x over 5, should be equal to 9 over 1. I multiply both sides by 5. The 5 and 5 get cancelled out, and I get x is equal to 45 centimeters square. Again, I can just put that in this equation, in this triangle, and we are done with this also. And moving on to our last question of the day. Well, this looks tricky. What we need to find out is the ratio of perimeters and ratio of areas. But before that, we need to find out the value of x first. What we have been given is that this line is parallel to this line that is already given in the question. So let's try and work it out now. How do we do that? Well, if this line is parallel to this line, that means this angle is equal to the corresponding angle here, and this angle is equal to the corresponding angle here. since the lines are parallel. So that is the property of parallel lines. And since let us name the triangle also. So let us say this is A, B, C, D, E. So we can say that triangle ADE is similar to triangle ABC, and if they are similar, then the ratio of their corresponding sides has to be the same. Let's take it as AD over AB. So let us find that ratio first. So AD is equal to 2x plus 2, and AB will be 2x plus 2 plus x minus 2, since AB is this complete length. And obviously the plus 2 and minus 2, they can get cancelled out, and that leaves us with 2x plus 2 over 3x. So that's the ratio, which means that this ratio is going to be again the same as the ratio of AE over AC. So AE over AC, AE we know is x plus 6, and AC will be x plus 6 plus x minus 6. The plus and 6 minus 6 can cancel out, and we are left with x plus 6 over 2x should be equal to 2x plus 2 over 3x. I can just make this smaller and take it to the left. So then we cross multiply, we multiply this side by this and this by this. So we get 3x times x plus 6. That should be equal to 2x times 2x plus 2. We can divide both sides by 2x. So I divide this side by 2x and I divide this side by 2x. So I can get the 2x's can get cancelled out. The x and x here can get cancelled out. And then I multiply both sides by 2. The 2 and 2 get cancelled out here, and I'm left with, I can apply the distributive property then. So I get 3x plus 3 times 6 is 18. That should be equal to, again, the distributive property here. That should be equal to 4x plus 2 times 2 is 4. I subtract 3x from both the sides. So minus 3x minus 3x. This can get cancelled out. So I'll be left with x plus 4. That should give me equal to 18. I can subtract 4 from both the sides. So I'll be left with x is equal to 14. So if x is 14, then we can find the value of all the sides. Okay, so 2x plus 2 will be equal to 2 times 14 plus 2. 2 times 14 is 28 plus 2 is 30. So I can rub this off and write 30 here. Then x minus 2 is obviously 14 minus 2, which is 12. So again, I can get rid of this and write 12 instead. X plus 6 is 14 plus 6, so I can write that as 20. And x minus 6 is 14 minus 6, which I can write as 8. So now we can find the ratio of the sides. We don't need any of this, so let's get rid of this. The ratio of the sides of the corresponding triangles. So I can take any of these sides, this and this, or this and this. So let me take it as this AE over AC. So AE is 20 centimeters and AC is 20 plus 8, which is 28 centimeters. I can divide both of them by 4. So 20 divided by 4 gives me 5, and 28 divided by 4 gives me 7. So ratio of perimeters, we learned in the earlier examples that it is the same as the ratio of the sides. So the ratio of perimeters is obviously going to be equal to 5:7. The ratio of the areas will have to be the square of 5 over 7. That gives us 25 over 49. So the ratio of the areas will be 25 is to 49. Okay guys, that brings us to the end of the video, and we did quite a few problems with here. We in fact managed to do 3 or 4 different problems, and we also learned how to prove that the ratio of areas of similar triangles is equal to the square of the ratio of the corresponding sides of the similar triangles. Well, if you like this video, I would like to hear about it in the comment section. How did you find it? Whether you liked it, found it interesting or not, and whether you're waiting for future content from us or not. And if you really like the video, I would like that you share it with your friends also. Send them a link to the video, let them learn something out of it. And if you haven't subscribed to the channel as yet, this is the right time to do so. In the center of the screen you see the subscribe button. Just hit on that and you'll get subscribed to the channel. But do not forget to hit on the bell notification also, so that you don't miss out on any future content from us. And you can watch these videos on the left side shown on the left. And please like and share the video, and take care, and God bless.